In this video, we'll learn a new language construct in Python, the for loop. A for loop iterates through a list of elements. But we haven't used lists yet, so we need to take a quick detour to learn about lists, and then we'll come back to for loops. List is a type that is built into Python. A list can store 0 or more elements. We use square brackets to denote the beginning and end of a list in Python, and we use commas to separate list items. As I said, a list can contain 0 or more elements. A list with 0 elements is empty, so we denote it with open and closed square brackets that have nothing between them. So there's an example of an empty list. We can also have a list with 1 element. Or we could have a list with more than 1 element. So far, all the examples that I've done contain integers, but a list can contain any value. Here's another example that shows a list of strings. In our course, we will only use lists that contain elements of the same type. So for example, a list of integers, a list of strings, etc. This is not a restriction in Python, as Python lists can contain elements of any type. But in our course, every element in a list will be of the same type. We will learn how to design data definitions that use lists, but in this video, we are focusing on the language construct of the for loop. A for loop provides a way to access every element in the list, one at a time, starting from the first element, or leftmost element, and ending with the last element, or rightmost element. A for loop that accesses every element in our list of names, one at a time, starting from the first element and ending with the last element, would look like this. As we can see from the syntax highlighting, which is the color that Jupyter is showing the different pieces of code in, for and in are keywords in Python. That's why they're showing in green. Name is a variable, we'll talk more about that in a moment, and list of names is also a variable name. We can see that it's previously defined 2 lines above this example, but it's also often passed in as a parameter to a function, if we're using a list within a function design. Thinking about a generic example, in our class we use the for loop like this. For var, where that's a variable name, in, and then some list value. Var is the name of a variable. You do not need to have used this variable previously in your code, and in fact it's most common to create a new variable to use to access elements in the list. List value must be an example of a list. Most commonly in this class, we have a variable that is storing our list, like in our example above with list of names. When this for loop is executed, the variable var is first assigned the first value from the list, and then the code in the body of the for loop is executed. Next, the variable var is assigned the second value from the list, and then the body in the for loop is executed. This pattern continues until the end of the list. The body of the for loop, or the code that is executed every time we access an element of the loop, is demarked by indentation, in the same way that the body of a function is demarked by indentation. As you can see in the examples, we have two lines, currently just of comments, that are indented. Any code that is indented at least one tab more than the for loop is indented is part of the body of the for loop. What code you write in the body of the loop depends entirely on what problem you're trying to solve. Let's step through a short example. Note that this example is not part of a function design, but you will see examples with more context soon. I'll start by creating a variable named sum and assigning it the value 0, and a variable called list of numbers. And in this list, I'll include 3 integer values. Now I could write a for loop for n in list of numbers, where n is a variable that the for loop will use to access each element in the list one at a time, and list of numbers is referring to our list value that we see above. Inside the list, I'll say sum equals sum plus n. So the code on line 6 is in the body of the for loop. In this case, the body of the for loop has exactly one line of code, but it could contain more lines depending on the problem that we're trying to solve. So when this cell is executed and the for loop is executed, first, the first or leftmost element of list of number is assigned to n, and then the body of the for loop executes. In this example, the body of the for loop adds n to the sum. Then, the second number is assigned to n, and then the body of the for loop executes again. This pattern repeats until we've reached the end of the list, and now the variable sum contains the sum of all the elements in the list. So let's actually try this out. As the last line in the cell, I'm going to access the value stored in the variable sum. So if I run this cell, I expect sum to be created and assign the value 0, list of numbers to be created and assign the list containing the elements 4, 9, and 1. Then I expect the for loop to execute, as I described. And finally, we'll access the value of sum. So we would expect the value of sum to be 4 plus 9 plus 1, or 14. In an example like this, we expect the body of the for loop to execute exactly once per element in the list. If we were considering an example where a for loop was used inside the body of a function, we may reach a return statement inside the body of the for loop. In this case, the for loop stops executing immediately, and the return statement returns the given value to the function's caller.